AWS CloudFormation is an infrastructure as code service that allows you to model, manage, and provision AWS and third-party resources. With a template file that defines all our application resources, CloudFormation takes care of provisioning and configuring these resources. In this video, we will learn the basic structure of a CloudFormation template, how to create a template from scratch, and also set it up in a GitHub Actions to build and deploy resources to AWS. The template content will be dependent on the type of resources your application needs. For the scope of this video, we will see how to set up a AWS Lambda function and also an SQS Queue. The concepts and the tips you learn in this video can be used to build any CloudFormation template. Hello everyone, welcome back to this YouTube channel. If you're new here, my name is Rahul and I make videos on .NET, Azure, Cloud and DevOps. Without much delay, let's learn more about CloudFormation templates. Let's start setting up an AWS Lambda function that will be triggered by a message in an SQS. So here on my console, I will be using the .NET CLI to create a new project. I will use the .NET CLI to create a new Lambda project. So this will be triggered by an SQS message. So let's create using the Lambda.SQS template. This is going to create a new project in the current directory. Now it says it's created successfully. So let's see, and it has a source and a test folder. Let's also make sure to create a git ignore file. So let's specify .NET new and specify git ignore. And this is going to create a git ignore file as well. Let's open this folder in Visual Studio Code. So I'm using code and specifying dot to open the current directory. Here we have the source, the test, and also the git ignore file that we just created. Under the source folder, we can see there is a function.cs which has our function handler. This takes in an SQS event and simply logs these messages onto the console. We also have a test project which has a few function tests. However, for this video, we will be concentrating just on the source folder. With all this set up, let's make sure to commit this as our first commit. So let's specify initial commit with Lambda function and click commit these changes. Now, if you're new to AWS Lambda as a .NET developer, you can check out my video linked here and in the description below. However, if you don't build applications on .NET, you can still continue watching because most of this is about CloudFormation templates. Let's see how we can set up a CloudFormation template to deploy this Lambda and an SQS queue into AWS infrastructure. AWS CloudFormation is a service that helps you model and set up your AWS resources. Now you can spend less time managing those resources and spend more time writing your code. All we do is create a template that describes all the AWS resources that we want, and the CloudFormation will take care of deploying them. Using infrastructure as code, which is also referred to as IAC, which is basically creating code to deploy and create your infrastructure. This simplifies the infrastructure management. It allows you to quickly replicate your infrastructure, and you can also easily control and track changes to your infrastructure because you can keep all of this in your version control itself. When you use AWS CloudFormation, you are basically working with templates and stacks. Now, a CloudFormation template can be a JSON or a YAML formatted text file. Now, you save these files as .json, .yaml, .template or .text. CloudFormation will use these files as the blueprints to create your infrastructure. Now, when you use CloudFormation to manage your resources, you manage the resources as a single unit called a stack. So you create, update and delete a collection of resources by creating, updating and deleting stacks. Stack is how we will be managing the resources. So all the resources will belong to one stack that is deployed from a CloudFormation template. We will see these as we deploy the CloudFormation template into the AWS infrastructure. So let's come back to Visual Studio Code and add a new file. Now for the purpose of this video, I will be using the YAML formatted version of CloudFormation template. So let's create a new file in the root folder. So let's create this plus icon and specify deployment.yaml. You can pick a name that you prefer. While you can manually handcraft the full CloudFormation template, it's easier to use an IDE to generate parts of it. Now, depending on the IDE that you use, there are different extensions available out there. Now, since I'm authoring this template in VS Code, I will be using the extension CloudFormation, for which I will put a link in the description below. I have this extension already installed on my Visual Studio Code, but if you haven't, you can click the install button and this will install it into your Visual Studio Code as well. Now, once this is installed and set up, we can use it on any JSON or YAML file. All we need to do is press start and press the tab key to populate the template skeleton. So let's come back to our deployment.yaml file, type in start and press tab. Now this creates the basic CloudFormation template skeleton. The skeleton template includes several major sections. Out of these, the resources section is the only one that is required. Now you can see here there are different sections that's available and that you can use to define your template file. We will go through the main ones as we create the new template. Now, the resources section is where we specify the stack resources and their properties. And this is why this is required. So let's come back to our file. Let's give this a description. So let's specify CloudFormation demo. Let's make sure to put this in double quotes. And let's start defining the resources. Now, for our application, the first thing that we want is to deploy this Lambda function. So we definitely need to create a Lambda function using CloudFormation. So let's come back to resources. To create a Lambda function template, all we need to do is start typing Lambda and it will show you the different options that you can use within this template file. In this case, we need a Lambda function. This creates the basic structure of a Lambda CloudFormation template. This takes in few of the properties like function name, description, the handler, and also the code that's used for this Lambda function. So let's specify a description. So let's specify CloudFormation demo Lambda. Let's give this function a name. So let's specify YouTube-demo-CloudFormation. We need to specify the handler for our function. In this case, this is inside the functions.cs class and the function handler method. Now, if we come to the AWS Lambda tools-defaults.json, this already has the function handler specified. Now, the format this takes up is the assembly name, the namespace along with the class and the function handler name. So let's copy all of this and use this as our handler. Now, we don't need to specify a KMS key ARN. So let's delete that. Let's leave the memory size as default. Let's come back to the role in a moment. We need to specify a runtime for this Lambda function. In our case, the runtime is .NET 6. So let's specify .NET 6. Now we can specify a timeout for this Lambda function. So let's give this as 30 seconds. If you want to run your Lambda under VPC, you can give the configurations for that. But for now, let's remove all of that since we do not require it. We can also specify environment variables if we need using the CloudFormation template. Let's leave this as default and see how this will come up in our Lambda function. Now, to specify the code, we have a few options. You can either specify it as an inline function or you can upload this particular Lambda function as a zip file into S3 and use it from there. In this case, let's upload it to S3 and use it from there. So we can specify a bucket name. So let's specify YouTube-demo-CloudFormation-packages. Now this is where the Lambda function is going to be created as a zip and placed into so that we can use it from there. Let's also specify a key file, which will be the file name of the zip. So let's specify it as Lambda.zip. Now we can also specify a specific object version, but let's remove this for now. Let's also remove the explicit zip file because we just need the S3 bucket and the S3 key. So let's remove that and let's leave the tags as is. Now, based on your application and how you manage your resources, you can specify appropriate tags as required. Now, to deploy this Lambda function, we also need an S3 bucket. Now, we could create this S3 bucket as part of another CloudFormation template before running this template function. However, for demo purposes, I will be creating this manually. So let's copy this name. Let's navigate into AWS console. And let's go into S3 and create a new storage bucket. So let's click create bucket and specify the name that we just specified. and we can keep all the other options as default and click Create Bucket. Now if you're new to Amazon S3 and want to learn more about it, check out my video linked here or in the description below. We have the bucket successfully created, so all we need to do in our build step is to upload the Lambda.zip file into this particular bucket. We need to specify a role for this Lambda function so that we can define the role in the CloudFormation template itself. So let's come right above our Lambda function and specify IAM, and this will prompt the different options that we can use. Let's choose IAM role, which creates the template that's required for defining a role. So now we have the IAM role and also the Lambda function defined in here. So in this case, we can specify a name. So let's say Lambda function IAM role. To start defining the role, we first need to specify the assume role policy document. Now this is the trust policy that is associated with this role. The trust policies basically defines the entities that can assume this role. In our case, we are specifying this role to a Lambda function. We need to specify that it will be a Lambda function that will assume this role. Now to understand the format that we need to specify here, we can Google assume IAM and AWS Lambda. Now let's go into the AWS Lambda execution role and search for that in this documentation. Here you can see the template structure that's required for a Lambda role. Now when authoring CloudFormation template, you will mostly be depending on the Amazon docs and choosing the template sections from there. Now some of these places you might encounter the examples as JSON format, or in some other places you will have both as well. However, you can easily convert between these two formats. You can use the cfnflip.com, which will allow you to convert between JSON and YAML. Now in this case, since this is in JSON, let's copy this, put it in the cfnflip and specify flip. Now this is going to convert this into YAML format. So all we need is the assume role policy document section. So let's copy that and make sure to paste it inside our template file. So let's remove this and paste this particular section in here. Now we need to make sure that the alignment is correct. All we have specified is give the allow effect for the service lambda.amazonaws.com. This is what is allowing this particular role to assume this role policy. Now once we have defined that, we can start defining the policies that we need to allow. Right now, this is allowing all actions on all the resources and it has a policy name as root. However, this is not something that you want to give for a Lambda function. As a general rule of thumb, give the minimum required access for your resources. So let's remove this root policy name and let's add in a policy to just give this permission to write to CloudFormation logs, so that we can see the logs when this Lambda function runs. To find the appropriate template structure for writing to CloudWatch logs, we can again search for this and find this in the documentation. However, for now, let's copy and paste that I have already written out. So here we have the policy name, which is YouTube demo Lambda policy, and we have specified the version. And now the only difference is the action is limited to logs, create log group, create log stream, and also put log events. This will allow us to write the logs into CloudWatch. We have a basic IAM role setup which allows this function to write to CloudWatch. Now let's update this role property so that it will use this new role that we have just created. To do that, we will have to refer this particular role inside our role property in this function. Now if you search for AWS Lambda function, which is the type of this CloudFormation template, so let's go into Google and let's search for that, which will bring up the documentation for the AWS Lambda function. Here we can search for role, which will give what this value needs to be. So you can see here, this role needs to be the ARN of the function's execution role, which means right after this IAM role is created, we need to refer to the ARN of this role. Now to do that inside your CloudFormation, we can use functions. AWS CloudFormation provides several built-in functions that helps you to manage the stacks. Now in our particular case, we need to get the attribute value of ARN for our IAM role. So we can use the getAttribute function, which can be used to get the ARN property of our IAM role. So if you scroll down in here, you can see the YAML format for using the get attribute. This is the longhand format, and you can also use the short form, which is simply specifying a exclamation mark along with get att and the resource name that we need to use and the property associated. So in our case, we need the ARN property of this Lambda function IAM role. So let's scroll down to the role, remove this, specify exclamation and get att, and specify the Lambda function IAM role .arn, which is going to refer to the ARN property of this particular role. CloudFormation will take care of deploying this first and getting the ARN for us inside the Lambda function when that is created. Now, depending on how your AWS accounts are set up, you might want to prefix or suffix your resources with an environment name. Now, if you're having different environments in different accounts, then this would not be a problem. However, in some of the teams that I have worked with, we have all the feature branches and also the development branch going into one AWS development account. In these cases, we use a suffix at the end to determine which particular branch is this coming from. For this, we can use parameters inside the CloudFormation template. Now, parameters helps us to input custom values whenever we are running this template to create or update a stack. So let's come to the parameter section of our template file and add a new parameter. To create a new parameter, let's type in parameter, which creates the template that is required for that. Now this can take in a description. So let's specify this as the environment name. We can give this a type. In this case, this is going to be a string and there is no default value, which means when we are specifying this template, we will need to pass in a value for this. We can also change the parameter's name by updating this param name. In this case, let's specify this as environment. We can use this environment parameter name inside our Lambda function so that when it is created, it will have the appropriate name suffixed to the end. So in this particular case, let's say after the function name, we want the parameter name to appear here. So again, we can use a Lambda function. In this particular case, we can use the function sub, which is going to substitute a variable inside a string. Now, if you scroll down, you can see the format on how to use this with parameters. So if you see the YAML example, you can see here, all you need to specify is exclamation sub and give the variable name inside curly brackets and also a $sign before that. So let's use similarly. So let's specify exclamation and sub and also specify the dollar and the bracket and environment in here. This will append the environment value to the name that we have in our YouTube demo CloudFormation. With all that set up, we can now deploy this CloudFormation template. Now, before committing and pushing these changes, let's make sure that this template is valid. So if you come to a command line, we can use the AWS CLI, use the CloudFormation, specify validate template, and specify the template -body and give in a value for this. In our case, this is going to be a file path. So we can specify file : / and give the full file path for this file. So let's come back to our deployment.yml. Let's reveal this in a file explorer. Let's press shift right click on this and copy this as path. Now let's come into Visual Studio Code. Let's open a new file and paste the path template in there. Now we need to make sure that these are forward slashes. So let's select one of them and use Ctrl+Shift+L, which is my default keyboard shortcut, to select all the occurrences of that same selected element. And let's remove that and make them as forward slashes. With that, let's copy this file path and use this inside our console command. So let's paste this in here and press enter. Now this is going to run the validate template on this YAML file. Now as you can see, there is an error which specifies the metadata null values is not allowed. So inside the CloudFormation templates, we cannot have any null values. So if we come back to our deployment.yaml file, we can see here metadata has no value here. So let's remove that. Let's also remove the other properties that does not have any value. So in this case, let's remove mappings, conditions, and also let's remove the one outputs. With all that removed, let's rerun this And this time it successfully parses this template file, which is why it outputs this information, which is the description, the capabilities, etc. So with that verified, let's come back to our source code and let's say add CloudFormation template and commit this changes. Let's push this into GitHub. So let's say git push. This is already wired up to one of my GitHub repositories. So let's navigate into my GitHub account and navigate to the repository where this was just pushed into, which is YouTube samples. This is public, so you'll also have access to this. Now here we can see the CloudFormation-demo folder, which has the deployment.yaml file, which we just pushed up. Now let's set up a GitHub Actions so that we can build and deploy this into AWS infrastructure. Let's navigate to the Actions tab and create a new GitHub Actions. Now since this is a .NET code, it is already suggesting us to use the .NET template. So let's click Configure, which creates a base template for us. So let's update this name. Let's call this as CloudFormation.yml file. Now this template file already has some information to build the .NET application. So if you see, this has a name again here. So let's specify this as CloudFormation. This is triggered on a push on the branch's main and also on pull request on the branch's main. Now it has one job, which is build, and it runs on Ubuntu latest. This job has multiple steps. So let's go ahead and update these steps so that we can build and deploy this particular Lambda function into AWS infrastructure. So it uses the checkout, which checks out this source code for this repository into this particular build actions folder. And then it's setting up the .NET. Now it's using .NET version 5. However, ours is on 6. So let's update this to be 6.0.x. Now this specifies a .NET restore, which we can remove, which will automatically happen when we do the publish of this .NET application. So let's rename this build to be publish, which is also going to build the application. So instead of build, let's specify .NET publish. Let's remove the no restore flag, which means it will restore the NuGet packages, the step that we just removed. And we need to specify a few arguments for this. So let me copy and paste that in here and walk you through it. So here we have the .NET publish. It's specified as not self-contained, which means this is not an exe that runs on itself, because what we need is a zip folder. It specifies a runtime, which is Linux x64. This is because this is running on Lambda environment, which is Linux based. It specifies the configuration as release. And also it specifies an output folder as artifact/publish. Now this is the folder where the .NET publish will output its artifacts. Let's also make sure we have the correct path to the CS project file. Now in our case, we have this under CloudFormation demo, under source. Again, there is a folder CloudFormation demo, and it specifies the CloudFormation demo.cs proj. So here we are missing one CloudFormation demo, which is the root folder for this particular project inside the repository. So let's specify // and also give CloudFormation demo. So we have the correct path for our project file inside this publish command. Now this publish command is going to publish the contents into the artifact/publish folder. So as a next step, we can zip this and upload this to an S3 bucket. So let's come back, let's remove this test step, and let's add the action to zip this particular directory. So if you come to the right on the marketplace section and search for zip, we can see the actions that's associated for zip. So let's use the actions.zip and select into that. We can see the full marketplace listing if you click that link. And here we can see how to use this particular action inside our build pipeline. So let's copy this and modify this inside our YML. So let's paste this. Let's make sure this is formatted correctly. So this is installing the zip action, which is the one that we just saw. Now in our case, the working directory is the artifact/publish directory, because this is where we have published this .NET publish command. So let's change this to be the artifact/publish. For the zip name, if you remember in our CloudFormation template, we had specified it as Lambda.zip. So let's come here and change this function.zip to be Lambda.zip. Now we need to zip all the contents of the artifact/publish directory. So let's remove all this and just put a dot to specify that all the files are required to be zipped. Now with this action, it first installs the action and then it zips the working directory, which is the artifact/publish, which is where we have deployed all the output directory, and it names it as Lambda.zip. Let's make sure that this Lambda.zip is created in the root of this artifact folder. So let's also add a dot and put a slash, which will navigate it one directory back and place the file inside that. Now you could place the Lambda.zip file as you wish, but I'm just putting everything under the root folder, which is artifact in this particular case. Now once this step is run, we will have a Lambda.zip file under the artifacts folder, along with the publish directory, which will have all the contents that was published from our .NET publish command. Now we can upload these artifacts as GitHub build artifacts. So to do that, let's go into Marketplace again and let's search for artifact. And we can say upload a build artifact. So if we navigate into the full Marketplace listing, we will see how to use this inside our application. So let's copy this, which has the users statement, and let's paste that inside our YML file. Let's make sure that this is formatted appropriately and specify the appropriate values. So here we can specify the name as Lambda. We can specify the path to be /artifact, which is the directory where we have all our artifacts published into. Now this step is just to see the artifacts that your build step is creating. We will see this in a moment later. We need to upload this zip file into the S3 storage that we created so that our CloudFormation template has access to this zip file that we have specified inside the template. So to do that, we first need to give our build pipeline, which is the GitHub Actions, access to our AWS account. For that, let's come back to the search results under Marketplace. Let's search for AWS credentials and use the action configure AWS credentials for GitHub Actions. So let's click that and let's go into the full Marketplace listing. So we can copy the one that uses the secret key and the access and the region. So let's copy these and make sure to paste this inside our YML file. Let's make sure to fix the alignment. And now this needs an access key ID, a secret key, and also the region where this needs to be deployed to. Now, if we come back to our management console, you can see that this particular packages is in the AP Southeast 2. So let's use this same region. So let's come back and update the AWS region to be AP Southeast 2. Now, in this particular case, it is getting the access key ID and the access key from the secrets inside the GitHub Actions. So we can specify two values, which is the AWS access key ID and AWS secret access key. To specify these secrets, let's open the settings in a new tab and then navigate to these secrets and actions under that. Here we can create a new repository secret and enter a value here. So we need the correct property name. So let's copy the AWS access key ID and let's paste this as a secret. Now for the value that's required, let's go to our IAM and create a new user so that our GitHub Actions can use this. So if you go under users, you can create new users here. Now I already have a user created. So let's navigate to GitHub user demo. Let's go to security credentials and create a new access key. So let's click create access key. Let's copy the access key ID. Let's also show the secret access key, which we will require in a moment. So let's make sure to keep that in our clipboard. And let's come back to our action secrets. So let's use Windows V for the clipboard manager and select the access key ID in this case and click add secret. We also need to specify the secret. So let's come back to here. Make sure we have the correct name. So let's copy this. Let's come back to action secrets, new repository secret, and specify that, and also use clipboard manager and specify the secret that we just copied and click add secret. So we have these two values specified in our repository, which will be accessible to this GitHub Actions when it runs. With the GitHub Actions having access to our Amazon account, let's upload the file into Amazon S3. So let's create the run task to upload this. So let's specify a name. So in this case, dash name. We can specify upload to S3. Let's specify run, which will run the command that we are specifying here. So in this case, we can say AWS S3 and use the cp command, which is the copy. We can specify the file. In this case, it is going to be under the artifact folder and it will be the Lambda.zip. Let's specify the bucket name. So if we come to our CloudFormation template, we have the bucket name inside here. So let's copy that and make sure to specify S3 : and give the bucket name as well. Now this is using the AWS CLI to run the copy command and copies this Lambda.zip into this bucket. Now once we have the Lambda.zip inside the bucket, we can start using this from our CloudFormation template. Now before publishing these artifacts, let's make sure our CloudFormation template is also included here so that we can use it in the next job, which will be the deploy job. Now this is just building it and we can have another job to deploy this. So let's go before the upload artifact step. Let's add a new step. Let's specify this dash name. Let's specify copy CloudFormation template. This can again be a run command. So let's create a run command. Let's use the copy task. In this case, we have the file under the CloudFormation demo and deployment.yaml file. So let's copy this CloudFormation demo. Let's specify that. So let's say ./CloudFormation demo /deployment.yaml. Now this is going to copy this file into the artifacts folder. So let's specify ./artifact/deployment.yaml. So this is simply copying this file into the artifacts folder so that it's available as part of the artifact. Let's commit this file and see if everything is working as expected. So we need an artifact folder which will have the deployment.yml file, and also this should be uploaded to the S3 bucket. So let's say start commit. Let's specify add GitHub Action to deploy to S3 and click commit new file. Now you can either commit directly to the main branch or create a new branch and raise a pull request. For now, let's commit directly to the main branch. So once we save this, this is going to trigger a new action. So let's open this in the new tab and you can see the action has already triggered because this is triggered on a push to our main branch. So let's navigate into this and we can see the steps that's getting executed. So we have one build job. So let's navigate further into that and we can see this is now getting the zip action and it's running all the actions and steps that we have set up. The build step has successfully completed, so you can see all the tasks that it has done inside this log. Now if we navigate to our AWS console, let's navigate to S3. If we go to the YouTube demo CloudFormation packages, we can see a file Lambda.zip. Now if we also come back to our GitHub Actions and go to the summary, we can see one artifact inside here. Now if you click this, you can see there is a Lambda artifact. We can also download this and inspect to see what is inside that. So let's click Save As. Let's save it in the Downloads folder and name this as Lambda.zip. So let's open this folder and open the Lambda.zip file. Here we can see there is the published directory. You also have the Lambda.zip and the deployment.yaml file. This is exactly how we organized the artifacts folder inside our build step. Now with all this set up, we can start deploying this into our AWS infrastructure. For this, we will use the CloudFormation template that we had written initially. So let's come back to our actions and let's edit this action. So let's say view workflow file and click the edit button. So we are now back in the edit mode. So let's add a new job to deploy this into a test environment. To create a new environment, we can go into settings and go into environments and create a new environment. So let's click new and specify this as test and say configure environment. You can specify appropriate policies in here, but right now let's leave it as default. So we have one environment test. We can use this to manage all the test resources inside GitHub Actions. So let's come back to our GitHub Actions. Let's add a new job. In this case, let's specify test-deploy we need to specify the runs on. So in this case, this is also going to be Ubuntu latest. We can specify the environment that we just created. So let's say test. For the test deploy job, we need to make sure that the build job is completed. So let's specify the needs attribute and specify the build as required. So this will wait until the build job is completed. Now as a first step, we need to download the artifact. So let's search for the action download artifact. So let's select that. We can go to the full marketplace listing and copy the usage for this. So let's copy the one which copies this to a specific directory. So let's copy this usage, come back and use this inside here. So let's define steps and paste this under that. Let's make sure to align this correctly. So this uses the download artifact. So our artifact's name is Lambda, and let's make sure to copy this into the artifact folder. We need to again specify the AWS credentials because this could be running on a different machine. So let's copy this exactly and use this again. So let's make sure it's under the right place and fix this formatting. So this again configures the AWS credentials. And finally, we can use the CloudFormation template. So let's go back into Marketplace search results. Let's search for CloudFormation and select the AWS CloudFormation deploy stack action for GitHub Actions. So let's go into the full marketplace listing and let's copy this and use it inside our YML file. So let's come back here, make sure to paste this, fix this formatting. So let's specify our stack name. So let's say YouTube-CloudFormation-demo. We can specify the template file, which is going to be in the artifacts folder. So let's specify artifact/deployment.yaml. Let's specify the template file. In our case, this was right downloaded into the artifact folder and it's named deployment.yaml. And also specify any parameter overrides. Now we had one parameter which was environment. So let's copy that. Let's remove all of this and let's specify environment is equal to test. So we're deploying to AWS CloudFormation and the environment is test in this case. So we can give a dash in here if we want the names to be separated with a dash. Now with that, let's say start commit, deploy using CloudFormation and commit it right into main. This would have triggered a new action. So let's navigate there. Now you can see there are two jobs. One is build and the other one is test deploy. The test deploy requires the build, which is why this is waiting for this to complete. Now once the build step is completed, it will trigger off the test deploy automatically. So the build is successful and it has automatically triggered the test-deploy. So if we navigate into that, we can see it's first downloading the artifacts and it has started deploying the AWS CloudFormation. So now if you navigate into our AWS console, if we navigate to CloudFormation, we can see the stack that is getting created. Now make sure you are in the correct region, but here you can see that the YouTube CloudFormation demo stack that we were just trying to create has errored out. So if we navigate into that, you can see under events, the different events that was getting created. Now here the template has some error which says the value of property path must be of type string. Now this is for the Lambda function IAM role. So if we come back to our template file, we can see here there is an extra path which is empty in this case. Now this is some error that has happened when I was copy pasting the assume role policy document. So let's come back to our console. Let's make sure to do a git pull so that we have all the build.yml changes in our local as well. So if we navigate into this folder, we can see there is the YouTube samples and we have the entire GitHub workflows created as well. So let's come back to our deployment.yaml. Let's remove this extra path attribute and let's make sure to fix this formatting in here. Now once that is set up, let's save this and commit this into our changes. So let's add all the files and let's commit this and say fixed extra path attribute. And let's push this changes into our repository. Once that is pushed, let's also make sure to delete this so that this will not create any problems for the next deployment. So let's delete that. So there is no stack right now. So let's come back to our actions, and here we have a new build automatically triggered. The build step is complete and it started the test deploy. So we can come back to the CloudFormation, and if we refresh here, we can see that the creation of this stack is complete and is successful. So if we come back to here, and this GitHub action has completed successfully. So if we come to our stack, we can see all the resources that is part of this particular stack. Here we can see there is a Lambda function, and it also has a Lambda function IAM role. So we have successfully set up a Lambda function all the way into our environment using CloudFormation template. Now we can come back and update our template to add the SQS Queue as well. So under the resources, we can type in SQS to create an SQS Queue. So let's type SQS, and this will create the template for the SQS Queue. Now we can specify a queue name. So let's again use the similar way we used to define the function name. So let's use the environment and the substitute function. So let's copy that, come back and use YouTube CloudFormation -queue and the environment. We can leave all of these properties as default. So let's remove all of them and simply leave this with the queue name property. Now if you want to control any of these properties, you can very well set those properties values inside here. Now with the queue created, we can wire this queue to be the trigger for this Lambda function. For that, we need to first allow this Lambda role to get access to this particular queue. So let's add a new policy. So again, let's come under the policy document. Let's go to the appropriate place, and I have already written this. So let me paste this required policy. This policy allows this SQS to receive the message, to delete the message, to get message attributes, and also to change the message visibility. Now this again uses the getAttribute function, and it specifies the SQS Queue.arn. So if we come back here, this is going to refer to this SQS Queue and get the ARN property for that and use that as the resource value. So these actions are only available for this specific SQS Queue. To trigger this Lambda function, anytime a message is coming into this SQS, we'll need to create an event source mapping. Now if you come back to Google, if you search event source mapping Lambda, you will see the information for that. How I figured this out? Again, I used the documentation to find that this is how you can wire up an SQS with a Lambda function. So anytime you're creating a CloudFormation template, you will be heavily relying on this documentation from AWS and looking at what properties and how it has to be set. Now this is a one-time activity, so you will have to spend some time to understand what are the appropriate values. Now I have already created this event source mapping, so let me paste that inside here and show how that works. Let's make sure to align this appropriately. So here we have the event source mapping. It's setting up the batch size to be 10. Let's also specify the event source ARN. In this case, that's the SQS queue, and the function that needs to get triggered. So that is again the Lambda function, which is in this and using the get attribute, and it gets the ARN for that. So this sets up a source mapping for this SQS queue to trigger this Lambda function. So let's come to our command line. Let's add all the changed files. Let's commit this and specify add SQS queue and trigger. And let's push these changes. Now this is going to trigger a new build action. So let's come back to our GitHub Actions. Let's come to Actions, and this has triggered a new build action. Now once this is complete, this should be building and deploying a SQS queue and also set up a trigger for that. The build is successfully completed and the deployment is underway. So if we come back to our CloudFormation, we can see that there is an update in progress. So if you navigate to events, you can see the different events that's getting triggered. Here you can see that the SQS queue is getting created right now. You can also see the resources, which will be appearing right here. Now you can see this function name has the dash test that we had appended from our environment inside the CloudFormation parameter. Now when we create the queue, that will also have the dash test. The update is complete. So if we come back here, this would also be successful in a moment. So if we come back to the resources, we can see there is an SQS queue created and also the event source mapping. Let's navigate to this CloudFormation test Lambda, and under the configuration, we can see under triggers that there is a SQS trigger that's set up successfully. So let's navigate to this queue test and let's add a new message here inside this queue. So let's navigate to this queue. Let's say send and receive messages and select a message which is test message and click send messages. If you're new to Amazon SQS, I highly recommend checking out my video that will be linked here or in the description below. So let's click send message, which successfully sends the message. Let's come back to our Lambda. Let's go to monitor and see view logs in CloudWatch. Now, since we had created the permissions for these logs, we can see these messages inside here. So let's navigate to one of the logs and we can see processed message, test message coming up here. So we have successfully set up using CloudFormation, the Lambda function and an SQS queue, and we have wired this SQS as a trigger for our Lambda function. Now this is currently deployed to the -test environment. You could also create a new environment inside our GitHub Actions and deploy this into the different environment. So let's say if we come back to the settings, we can create an environment, let's say a new environment. Let's specify this as prod and click configure environment. So let's say required reviewers, and we can also specify the people that needs to approve this if something needs to go into the prod environment. So let's choose myself for now and say save protection rules. So if we come back to YouTube samples, let's go into the workflows. Let's go to CloudFormation. Let's edit this and let's duplicate this particular job. So let's say test deploy. Let's copy that. Let's paste this again here. Let's make sure to name this as test prod. This environment is production. So let's say prod, which we just created. And in the parameter values, we can specify this as -prod. Or we can also leave this as empty if you don't want any values to be passed in for prod environments. So let's click start commit and say added prod environment and commit the changes. Now this is again going to trigger a new action. Now here we have named two ones, which is test prod and test deploy. This name should have been prod deploy. Now if we navigate to the workflow file, we can edit this. So instead of test-prod, we can specify prod-deploy. We also need to make sure that the stack name that we specify is different. So here, this is going to deploy to YouTube CloudFormation demo. So let's specify the name as -prod so that it doesn't create a conflict. And let's click start commit again and specify update prod name and stack name and click commit changes directly. Now this is again going to trigger a new action. So let's wait for that to deploy this into production environment. For the previous build, we can prevent deploying that to prod because the naming was not correct. So let's come back to our new build and let's promote this particular prod deploy into the production environment. So let's click review pending deployments. Let's say prod and let's say approved for deploy and click approve and deploy. Now this is going to trigger that job and deploy this into production. Now if you look at the test deploy, this has failed. So if you look at the message, it says failed to create a change set. The submitted information didn't contain any changes. This is because the CloudFormation template didn't see any changes to deploy for this particular deployment step. In these cases, we can come back to our actions. Let's go to our view workflow file. Let's edit this and let's search for that task, which is the CloudFormation. So if you look at the task that we used, let's navigate to the full marketplace listing. And this specifies here that this error will fail if the change set is empty. To prevent this, we'll need to set the no fail on empty change set to be value 1. So let's copy that again. Let's come back to our CloudFormation.yml. In the steps where we are using the CloudFormation, let's specify this property. So let's specify in here no fail on empty change sets and also do the same for production so that it will not fail when it's an empty change set. And click start commit and say no fail for empty change set to 1 and commit these changes. Now if we navigate back to actions, the update prod is still running. So you can see this is deploying to prod, and you can see the progress inside here. So if we navigate back to CloudFormation, if we navigate to stacks, you can see the one with dash prod. So let's navigate to that, and you can see all the events inside here. So once this step is complete, we will also have successfully deployed to the production environment. Now, based on your account setup, you might have production in a completely different AWS account. So you can see the production one is also complete. So if we navigate to resources, we can see the production resources. So if we navigate to the Lambda functions, we can see the specific Lambda function for production. If you navigate to functions, you can also see the two functions that we have. This one is for the test, and this one is the production environment one. So if we navigate back to our GitHub Actions, let's navigate to the actions, and let's see the one that has no fail on empty Changeset, and you can see the latest test deploy has also succeeded, even though there was no changes for this particular deployment. I hope this helps you to understand more about CloudFormation and how to set this up in GitHub Actions. We learned about the template structure for CloudFormation, how to create one from scratch, and also set it up to deploy using GitHub Actions. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, please make sure to hit the subscribe button. It will also help me to grow this YouTube channel. Thank you, and see you soon.